Hello, everybody. This is Mr. Fabianski here, and today I would like to take you through some notes on matter classification. Okay, so we're going to look at classifying matter today. So the first thing I'd like you to think of is about water and granite. All right, so water and granite, are these examples of matter? So think to yourself for a little bit. Excuse me. And we would say the answer is yes. Yes, they are examples of matter. All right, well, let's ask another question. Are they the same type of matter? And if we think about this, we're going to say no, because one is a liquid and one is a solid. Okay, so we have two different states of matter, a liquid and a solid, but they are both considered to be matter. They both have mass and volume. We know that the water is a liquid. We know that its shape and volume are both, its volume is definite while its shape is indefinite. And with granite being a solid, we know that its shape and volume are both definite. This should all be review. All right, well, let's take a look at an example of water and table salt. So this is our first example. Let's look at our second example of water and table salt. And if you're playing along at home, table salt is really just sodium chloride, NaCl. So are these both examples of matter? And the answer, let's see, examples. Excuse me, of matter. And the answer to that is yes again. All right. The second question, are they the same type of matter? Oops. Same type of matter. And the answer to this is no. Again, we have a liquid with water and a solid with sodium chloride. Again, I apologize, guys. I promise I will get better at this with writing, but I'm writing on the surface and it takes a little bit of getting used to. So, all right. So what makes water different from granite, but the same as salt? All right. Because obviously water is a liquid, both cases, but granite and sodium chloride, they're both solids. Okay, technically they're the same type of matter. All right, but they're slightly different. Okay, and we want to break down further, why is granite not the same, equals with a dash through it, as salt? What makes them different? Okay, what makes them different? And the answer is their classification. See, I told you, we are learning about classifying matter today, matter classification. So this brings us into our first major point. All types of matter can be broken down into two categories. All right. All types of matter can be broken down into two categories. All right, and those categories would be 1, mixtures, and 2, pure substances. Now in science, we abbreviate a lot. You may have noticed that when I had written reaction, I abbreviated it with an RXN. All right. Same case here. Instead of writing substances, I just simply abbreviate it with SUBS. All right. So, what is a mixture? A mixture can be separated by physical means. So what does that mean? We're talking like filtering, okay, filtering out a substance. Filter. We're talking distillation. That is where you have a liquid and you boil it off, and then you condense it and gather it in a different space. All right. Mixtures are also, it's my arrow, mixtures are also a blend of two or more types of matter. Oops, sorry about that. Blend of two or more types of matter. Okay. Let's see. Now, what about a pure substance? A pure substance has a fixed composition. Okay, meaning whenever you have this substance, the ratios will always be the same. You make this substance the same way every single time. It's always made up of the same exact components in the same exact ratios every single time it's present. With regard to a pure substance, every sample of a pure substance every example of a pure substance has the exact same properties. Okay, every example of a pure substance has the exact same properties. We just talked about this. No matter if you have a pure substance that looks like this, and you just take this little bit right here, this little bit will have the same exact properties as this piece over here, or as this piece right there, or as this piece right here. No matter what, they will always have the same exact properties. All right. So let's take a look at granite and water again. Okay. Let's go back to that granite and water. So what would you say water is? Is it a mixture or a pure substance? Remember, water is H2O. Correct. Water is a pure substance. Water will always be in that ratio of 2 to 1, 2 hydrogens to 1 oxygen. No matter what it is, it has a fixed composition. Granite, on the other hand, if you've ever seen a piece of granite, granite is a mixture. It's a mixture of different minerals, different materials that go into it. All right, so we now have a mixture. It's a blend of 2 or more types of matter. We have a mixture and a pure substance. So can you guys think of other examples of mixtures and pure substances? A mixture, what about air? That's a mixture of different types of gases, right? Maybe a pure substance would be something like sodium or lithium. I know those are elements, but they're also pure substances. Or sodium chloride, like in the example above. All right, excellent job, guys. Let's keep moving on. So I'm excited to tell you that we could break these categories down, mixtures and pure substances, even further. And at the very end, we will make like a flow diagram, a flow chart, so that you can see how we can classify every single type of matter out there. Very exciting, guys. I know you are on the edge of your seat, excited to see what's next. All right, so let's classify those mixtures. All right, here we are. So mixtures. Let's take a look at air and chicken soup. So we have air and chicken soup. Those are both examples of mixtures. Air has different gases such as nitrogen gas, oxygen gas, argon, helium, so on and so on. Where chicken soup is a mixture, right? Is a mixture of chicken, water, maybe some celery, carrots, etc., etc. It depends on what you put in your chicken soup. All right, so even though they are both mixtures, they're different. If you were to look at the air in front of you, it looks all the same. But if you were to look at chicken soup, you got this bowl of chicken soup, right? And then you got these little pieces in there. You got some other stuff in there. I don't know if there's red stuff in your chicken soup or green stuff, but you guys get the point, all right? It's different. Where air is just kind of like, it's all the same regardless. It just looks the same. So how are they different? They're different because you could see a difference. You can see a difference with chicken soup. Right? You can see the components of it. With air, you can't see a difference. Air, everything looks uniform. There is no difference. Okay, so what can that tell us? Well, that gives us two other types of mixtures. Air, we say, is a homogeneous mixture. Oops. Okay? It has a uniform composition. Displays a uniform composition, and comp for composition. Whereas chicken soup is a heterogeneous mixture. All right, it is not uniform. In composition. You could see all the different parts. All right, guys. All right, excellent, excellent. All right, let's keep going. So we've taken care of matter. And we've said, let me write it down here. We have matter. And we said, well, matter can either be a pure substance or it could be a mixture. And then we just learned that mixtures can either be homogeneous with uniform composition or heterogeneous. Okay, with not uniform composition. So we're going to continue to work on this classification diagram. But before we can do that, we have to add some stuff over to this area. We have to break down the pure substances. Okay, so let's keep on going. So now let's talk about pure substances. So what are pure substances? Well, we gave an example of maybe Ca, which is calcium, and CaCl, calcium chloride. These are both pure substances, but they're different. They are different pure substances, but how are they different? Well, if you remember, maybe from general science or your 8th grade science class or any of your middle school classes, that calcium is an element and calcium chloride is a compound. Here's another fun abbreviation, CMPD for compound. So you have an element and a compound. Well, guess what? Both are examples of pure substances. All right, so, but how do you know if something is an element? How do you know if something is a compound? I mean, you guys just can't look and say, I mean, we haven't gone through enough chemistry to know, hey, that's a compound, that's an element. Is there a foolproof way to tell us if something is an element? That's the major question. Put this in blue. Is there a foolproof way to tell if something is an element? Can't forget our English there, right? And because we have a vowel on the next word. And the answer is yes, and I'm very excited to tell you this. All you have to do is look at my friend and your soon-to-be best friend in the world, periodic table. Woohoo, the periodic table. Anything, if it is on the periodic table, it is an element. It is by definition an element, okay? Anything on the PT, the periodic table, is an element, okay? I don't know about you, but it was weird writing in all caps right there. I apologize. But anything on the periodic table is an element. Very good. All right, well, how can we relate this to compounds? Well, guess what? Compounds, remember that abbreviation, compounds? Compounds are made up of two or more elements. So if you see something that is just an example of something that is on the periodic table, if you see a piece of matter that is by itself on the periodic table, sodium, lithium, potassium, carbon, oxygen, nitrogen, antimony, yes, antimony, Sb, iridium, osmonium, that's a capital O, barium. These are all elements. They are by themselves. But if you see something, sodium chloride, water, H2O, calcium chloride, methane, carbon tetrahydride. These are all examples of compounds. They are made up of two or more elements, okay? Those are all examples of two, but they're made up of two or more elements. C6H12O6, right? Sugars. You learned that in biology, I hope. Those are examples of elements. All right, excuse me, compounds. So now, let's take a look at the best part of today, and that is our final matter classification diagram. So here's matter. We have matter to begin with. From here, a substance matter can either go one of two ways. It could either be separated by a physical means or not. Separated by physical means, and if that's the case, it is a mixture. All right. If it cannot be separated, if you cannot separate it by a physical means, and again, physical means, we are talking about filtering. We are talking about distillation. What other physical way? We're talking about going in and picking apart. All right, separating it physically. We're not changing it in any way. We are not doing any of that stuff. We are separating it in a physical means. We're boiling it. We're not separating that. We're not changing that chemical composition. That's what it means by physical. It is a mixture. If you can't separate it, then it's a pure substance. All right. Now, if it's a mixture, let's go back over to mixture, right? We're going back over to here. If it is a mixture, from here, we can go one of two ways again. We can either have it be uniform in composition, and if that's the case, it is a homogeneous mixture. All right. And remember, we gave an example of this. This was just like air, right? It looks the same. It's a mixture that you can't see a difference. But if you could see a difference, if it is not uniform, it is a heterogeneous mixture. And remember, we said this is not uniform. Okay, not uniform. All right, well, let's jump over to the other side. Let's jump over to pure substances. Pure substances, again, we can have two different tracks. We can have a compound, or we can have an element. And remember, how do we determine an element from a compound? Well, if it appears on the periodic table, right? Appears on periodic table, it is an element, and compounds are just combinations of two or more elements. So two or more elements. All right, and there we have our classification of matter. All right, very, very important. Just one last little piece of information. When we talked about separating by physical means right here, we said filter, we said distillation, picking apart by hand. Well, there are ways to separate pure substances. You could do that through such ways as electrolysis. And what this basically is doing is adding electricity to break apart the elements, break apart the compound. So here we're breaking bonds. All right, so we are not separating by a physical means, it's by a chemical means. But always ask yourself, are you separating by a physical means? If so, then you are a mixture. All right, guys, I hope that this has helped. Go through it, make sure you copy this down into your notebooks. I hope you all have a great rest of your day. Everybody, take care. This is Mr. F saying, chemistry is life. Enjoy it. Live it. Learn it. Love it. Have a great day, everybody. Bye.